Let's solve a problem about finding the speed of a distant galaxy using the Doppler effect. We'll use the redshift of hydrogen light from a distant galaxy to calculate how fast it's moving away from Earth. First, let's understand what information we have and what we need to find. In the laboratory on Earth, hydrogen emits red light with a wavelength of 656 nanometers. When we observe light from a distant galaxy, this same hydrogen line has a wavelength of 691 nanometers. Notice the wavelength increased from 656 to 691 nanometers, which means the galaxy is moving away from us. The light waves are stretched out, or redshifted, as the galaxy moves away from us. The wavelength increases from 656 to 691 nanometers. We'll use the Doppler effect formula for light to solve this problem. The Doppler formula relates observed wavelength to emitted wavelength. Lambda observed over lambda emitted equals C plus versus over C. Lambda observed is the wavelength we observe from the galaxy, which is 691 nanometers. Lambda emitted is the wavelength the hydrogen actually produces, 656 nanometers. V is the velocity of the galaxy that we're trying to find. And c is the speed of light, 3 times 10 to the 8 meters per second. Now let's substitute our values into the Doppler formula. The observed wavelength is 691 nanometers. The emitted wavelength is 656 nanometers. Substituting these values, we get 691 over 656 equals C plus versus over C. Calculating the left side, 691 divided by 656 equals approximately 1.0533. Now we'll solve this equation to find the galaxy's velocity. Starting with our equation, 1.0533 equals C plus versus over C. Multiplying both sides by C gives us 1.0533 times C equals C plus V. Subtracting C from both sides, 1.0533 C minus C equals V. This simplifies to 0.0533 times C equals V. Now we substitute the speed of light. V equals 0.0533 times 3.0 times 10 to the 8 meters per second. Calculating this gives versus equals 1.60 times 10 to the 7 meters per second. Let's also express this velocity in kilometers per second for clarity. Converting, 1.60 times 10 to the 7 meters per second equals 16,000 kilometers per second. This means the galaxy is moving away from us at about 5.3% the speed of light. The galaxy is receding from Earth at 16,000 kilometers per second, which is why we observe the redshift in the hydrogen spectrum. Let's understand what this result means physically. The positive velocity confirms the galaxy is moving away from Earth, not toward it. This redshift is actually due to the expansion of the universe itself, not just the galaxy's motion. In general, galaxies with larger redshifts are both more distant and receding faster from us. Let's summarize our solution. We were given the laboratory wavelength of 656 nanometers and observed wavelength of 691 nanometers. We used the Doppler effect formula for light to relate these wavelengths. We calculated the galaxy's velocity as 1.60 times 10 to the 7 meters per second. This is equivalent to 16,000 kilometers per second, or about 5% the speed of light. This velocity indicates the galaxy is receding from Earth as part of the overall expansion of the universe.